Hey, what's up, guys? In this video, I'm going to go through this Leetcode number 994, rotten oranges. So we are given a n by n grid, where each cell has a one of three values represented three states. So 0 means a empty cell, means there's no orange, and 1 means the orange has a fresh, so there's a fresh orange in the cell. And 2 means that the orange in the cell has been rotten. Every minute, any fresh orange that is 4 directionally adjacent to a rotten orange become rotten. So we need to return the minimum number of minutes that must elapse until no cell has a fresh orange. And if that's impossible, and you return a negative one. Let's take a look at this example in here. In this grid, the orange on the top left corner, this guy's rotten, so we can infect this guy, also infect this guy, because 4 directional means in the same, we can move along the row or we can move along the column, but it does not go the diagonal. So the next period, this orange is rotten and this orange is rotten, and then these two are fine. And then in this stage, the minute number 2, and this guy get infected, and this guy get infected as well. So as you can see, for orange that immediately get infected, they don't pass along the DC in the same minute. They will infect the DC to the next orange in the next minute. So that's why it slowly infect all the orange over time. So the next stage, because these two guys are newly infected, and this guy has no one to infect, and this guy can infect this orange over here, and this guy getting the rotten, and then the last one get infected by the one just next to it in the minute number 4, the 4th minute. As you can see, so it takes in total 4 minutes. Goes from the first stage to the last stage where all the orange get rotten. And we can walk. You can walk through this question by yourself, because in this stage, so graphically it looks like this. So this is the grid, right? So 2, 1, 1, 0, 1, 1, and 1, 0, 1. And this guy over here, there's no orange, adjacent orange. So this is guy 0, and this guy's 0 as well. And so there was no one infected. And also, so itself is also fresh orange. So these guys never get rotten, never. That's why for this grid, so it's impossible that all of the orange will get rotten in the future. So in this case, it's returning a -1. And we will, in a code, we will implement together later. There was some part to handle this edge case. And for this one, there's only one orange, and it's rotten at the beginning. That's why it takes 0 minutes for all the orange become rotten. Yeah, so that's the 3 examples they have given to us. And let's look at how many companies. So ask this question in the past 6 months. So as you can see, Amazon is crazy about this question, and also there are other big names, Microsoft and Google and Amazon. It's not Amazon, Walmart, Samsung, Facebook. So right now, let's walk through the code and implementation together. I will talk a little bit about the algorithm during the code. So we first need a number of rows and number of columns. So pretty standard way to do it. Just measure number of rows and also take the first row. Okay, how many columns in it? And we need to handle this corner case. The sum grid basically is summing all the numbers in the grid, right? So we sum it across the column first, and then sum across the row. And then if it's equal to 0, that means there's no orange at all. All the number in the cell on 0, because the number must be positive. If that's equal to 0, that means all the orange, there is no orange in the grid. Basically, in that corner case, we just return a 0. And in here, we just looking at for the 4 directionally adjacent requirement, right? So these 4 directions, they are -1, 1. So we move to the next column on the left, the column on the right, the row above, and the row below. So that's 4 directions. And then we need 2 sets. One set is called rotten. Let's keep track of what coordinate that contains the rotten orange. So for example, in this case, for the first board, right, for the first minute, so this orange is rotten, so it will record 0 and 0 in the set. Also fresh, you keep track of all the orange. That's fresh, meaning that is have the number 1 on the grid. Okay, and there are 2 helper functions that I will walk through with you after I go through the following loops. So you know what's the purpose of them. And there's a for loop in here. So that's the first double for loop that we're looking at. We have another one later. And the first for loop that we need was to collect all the information for rotten and the fresh at the beginning. So if the number is equal to 2, we are coming across a rotten orange. So we collect each coordinate by adding to the rotten set. And also, if that number is 1, that means it's a fresh orange. And then we just push the coordinate to the fresh set. And this is the corner case, right? And this will handle exactly this. So that means if the coordinate is isolated from others, so as in this case, it's isolated, right? So there's no one above, there's no one to the right, but also it's at the edge, right? There's no more on the left, there's no more down below. That means it's isolated, and also itself is fresh, right? I mean, in that case, there's no way to infect this particular orange. In that case, we just can simply terminate the whole thing and then return -1 without running the rest of the code. And now let's walk through how can we see is it isolated or not. Right? So if we're looking at the row to the left, so this is to the left is not an edge, and to the right, sorry, so this one should be the row from above and the row from below. They are not on the edge, right? So there are some numbers in it. If that number is not equal to 0, so that means it's not isolated. There's some orange above, and then return the false. If the number below is not a 0, that means there's some orange below it. That means it is not isolated either. So we return a false as well. And then we check on the columns by the same logic. The columns on the left and columns on the right. If either of one of them is not 0, and then we automatically return the false. If none of these conditions are met, so that means the orange is isolated, and then we return a true. Okay, once again, if the orange is isolated and itself is fresh, that means there's no way to infect this fresh orange. In that case, we just return as -1. So yeah, so that's the first double for loop that loop through all the possible cells. And then the number of orange will equal to the number of rotten orange at the beginning, also the number of fresh orange in the beginning. And if all the orange, so this is another corner case, if all the orange are fresh, there's no rotten orange, that means there's no way to create even the first infection, right? So in that case, it's also returning a -1, which is no way to infect. And And then this is a for loop in here that simulate the rotting process, the infection process. And we have n infecting that keep track of how many infection for each minute, and also the minute, which is the number of minutes that will elapse. That's what we will return at the end. So you can see, we initialize the n infecting as 1 just to trigger this while loop running at the beginning. And there's no particular meaning for this 1, actually, this number. We just want to trigger this one for the first time. And because it runs at least once, that's why we initialize the minute to be -1. Because even it runs one time, even the condition is not satisfied, it runs one time, and then we return a 0 for the minute. That's why we have to initialize a -1, because you will plus 1 whenever this for while loop is run. It's being ran. And this while loop will be keep running when there are new infecting cases. As you can see, so the reason why I have this was for the first minute, there are 2 new cases, the 2 new infecting cases. And for the minute 2, for that particular point in time, there are 2 more new cases. For the 3rd minute, there are 1 more new case. And then for the last minute, and there's 1 more case. And then the 5th minute, there's no more case. The 6th minute, there's no more cases. This is where we're going to stop. So whenever there's new infection cases, and then this while loop will keep going, and that's exactly why I need this n infecting. And the infecting is a set that keep track of the newly infected cases. For example, for the first minute, so the infecting will be this coordinate, which is 0 and 1, and also this coordinate, which is 1 and 0. Right, so it's keep track of the new infected case. And this newly infected orange, they will not be infecting other orange until the next minute. That's why I have to have this infecting set to keep track of the new cases, because they don't have power until the next minute. So that's why. And as usual, we have 2 for loops to loop through all the grids for each iteration. And if the orange we are looking at is fresh, and we can infect it, so, and that means now this orange that we're looking at has been infected, and then we push it to the infecting set. Also, we move them away from the fresh set, because they are no longer fresh. They are infected at this point, so they will become rotten. So this infecting helper function, it looks like this. So it's pretty simple, right? It's only a few lines. So for all the directions, all the 4 directions in here, if they are adjacent, these are adjacent coordinate. If they are adjacent coordinate, they are already in the rotten. That means they can infect the orange, and then we will return a true. That means it can be infected by other rotten orange. If after we looking at these 4 directions, there's no rotten orange surrounding it from the 4 directions, and then we will return the false. Okay. So it's pretty simple. And again, if we can infect this guy, also this guy is a fresh orange, we will infect it by pushing to the infecting set, and then we will remove it from the fresh set. So the number of new cases, we just measure the length of it. And then the rotten orange set will incorporate the newly infected orange by using the union. So basically, it's the existing rotten orange merge with the newly infected oranges. And then this will be used in the next while loop. And then after 1 iteration, we just increase the minute by 1. So if in the end, if the number of total rotten orange is less than the number of oranges, that will return a -1. And this is handling this case, right? So basically what's going is something looks like this. So they come in a column, right? So in the next minutes, so this guy will be infected. I'm talking about this case in here, just so you know. And there's no way to infect this guy because it's empty. So and these two orange, they will stay fresh forever. And in this case, the total number of rotten orange will be 2, and it's less than the total number of oranges, which is in this case 5, right? So this code is handling this scenario. If after all this iteration, if the number of rotten orange is less than the total number of oranges, and that will return a -1. Otherwise, just return the number of minutes. Let's run that. It works. It looks okay. So for this number changes. For time complexity, so it's gonna be a you can see it a few times we look over the grid, right? And in this case, is in the first double for loops is the big O of n times m, right? We just iterate through the entire grid, and then we have another for loops in here. So basically, it's a the number of minutes times n by m. So in total, if we have this the two for loops together, still a linear time. Again, the first one is the first for loop takes m times n, and the second is the number of minutes times m times n. And for space complexity, we have rotten set, also the fresh set. So both of them take up, in the extreme case, it will take up big O of n times, big O of n space as well. Yeah, that's so much for my solution. I hope you like it. If you do, please like this video and consider subscribe to the channel. That will be a huge encouragement to me to create future videos looks like this. Thank you so much for watching. I will see you in the next video.